We're going to do a couple examples now of the different methods of solving problems that are parallel. Okay, first easiest rule for parallel circuits. My formulas have all dropped out. I cannot believe this. Okay, is RT is equal to R divided by the number. We did an example a little while ago, but let's just do one off the top of our heads. If we have 4 resistors in parallel, and we have 400 ohms resistance for each resistor, and they're 4 in parallel, this makes it nice and simple. 400 divided by 4, we think the resistance for the total thing is what? 100 ohms. Okay, so RT is 100 ohms. Okay, product over the sum. Now, let me tell you the advantage of product over the sum. You can do it with your daughter's 3rd grade calculator that cannot do square roots, that cannot do reciprocals, it cannot do hardly anything except add, divide, add, subtract, multiply, and divide. If you can add, subtract, multiply, and divide, you can do product over the sum. Now you say, how will that help me do 4 resistors? Because there are 4, there aren't 2. Well, let's say that we're going to look at resistor 1 and 2 as one thing. First, we're going to do product over the sum with them. Then we can do product over the sum with 3 and 4. And then we could do product over the sum with R1, 2, R3, 4, as though they were one single resistor in series, right? Or in parallel, I should say. So let's look at that. I didn't put any values down because I think we're just going to put some numbers in here. So let's say 250, 500, let's say 1,000 and 2,000. Now that doesn't look too easy, does it? That looks, I can't do that. That's too hard. Well, let's do product over the sum. So 250 times 500 divided by 250 plus 500. I bet you can see you doing it now, right? 250, we could use powers of 10 to simplify that and make it 25 times 5 times 10 to the 3rd, but let's not do that. We can see that that's going to be what? $125,000? Okay. Divided by 750, right? Okay, let me put that in my calculator real quick. So we have 250 times 500. Yep, 125,000 divided by 750. And we get 166 2/3 ohm. $166, 6666. In other words, 166 2/3 ohms. Okay, we're going to store that information, right? Now we're going to do 1,000 times 2,000. This one's even going to be easier. Divided by 3,000 is equal to, that's going to be what, 200,000 or 2 million? 2,000 times 1,000 is equal to 20 million? Let me try that again. Maybe I made a mistake. Times 2, 1, 2, 3 is equal to a big number divided by 3,000. And we get 666.66667. Okay? So now, however could we solve this whole thing and get our total resistance? We could have 666.667 times 166.667 over 666.667 plus 166.667. And once again, this is an easy enough problem that we could do it with the third grade calculator, or your third grader could do it for you. Okay, so we're going to multiply that times 166.66667, and that's equal to, and we're going to divide by, and I'm just going to make it simple on myself, put in a parentheses, 666.667 plus 166.667, close parentheses, and we get 133 and 1/3. Okay, and that's our RT. Oh, I put my RT in the wrong place, didn't I? I put all these things in the wrong place. Darn it. Simple move. I like that. First thing I've liked about this in a while. And we have a total of 133.33 ohms. That's our total resistance. Now, wasn't that easy? I mean, you could do that with any calculator in the world. You could even do it with pencil and paper if you really had to, right? You get in the field. So product over the sum is how you remember. Product is the result of multiplication. Sum is the result of adding things. So nice and simple. Let's go to the next slide. The second and very easy use formula for parallel resistance known as the product over the sum. We already did that. Most difficult, but the most useful is, you know what I'm going to, as somebody suggests, I'm just going to write in here 1 over RT equal to 1 over R1. Let's see, can I get rid of that? I don't think so. How's that? Plus 1 over R2. Oh, that's what that 2 is right there. Okay. Plus 1 over R3. Let's see if I can fix this a little bit. 1 over R2. Fix that. 1 divided by R1. Does that make sense to anybody? Okay, now let's go back and do another problem. Let me see if I've got a, oh, I thought I had another one of these. Let's see, let's take all this out. Let's see, how do I lose all, where's my expert? He's not here today. How do I lose all my ink? Let's see. Well, how about I take this out and I just do the whole thing? No. Come on. All right. So now we're going to use what's called the reciprocal rule. Pull out your handy dandy TI-30X2S. You don't have to have that exact calculator. You should not be here. It's in the syllabus. You must have that. And you're about to find out why it's so darn handy. I mean, the other calculators will do this. So it's not exactly true that this is the true reason to have it, but we'll talk about that later. Okay, now let's give these some similar resistances. Let's say this one is 200. Whoops, there we go, right in the resistance total again when I don't know that yet. Let's say R1 is 250 again. Let's say R2 is 500. Let's say R3 is 1500. And I say R3 is 2000. Everybody okay with that? Okay. Now, on your calculator, number one, turn it on. Turn it on. Okay, now I want you to hit clear twice. That's in the upper right-hand corner. It says clear. Hit that twice. It clears out the memory. You need to have the memory cleared out for this. Okay? Now, we're going to make this really simple. We're going to hit some keystrokes here, and you're going to follow along exactly as I say to do it. You don't need to understand how to do this. You just need to know how to follow the steps. So we're going to put in 250. Punch in 250. Now, right above the 7 button, there's an X to the -1 button. You're going to hit that button now. X to -1. Now you're going to hit plus. Hit plus. Okay, now we're going to put in, now don't hit anything else just yet. Put in 500. Just put in 500. And once again, we're going to hit that button right above the number 7 button that says X to the -1. X to the -1. Plus 1,500. Guess where? X to the -1? Correct. Then plus. And now we're going to put in 2,000. 1, 2, 3 zeros. X -1. Do not hit plus. Do not hit plus. We're not adding another number. Now we hit equals. Now what does that give us? That gives us the reciprocal of the resistance. 1 over resistance total. So what do you think we want to do with that answer? We want to hit X to the -1, enter, and it tells us that the total resistance for this circuit is 139.53 ohms. Everybody have that on your calculator?
Yes.
All right. We're going to do this again, and again, and again, and again, until you have this down. Okay, we're going to erase everything. We're going to do another example problem. All right? All right. Give me some resistance. 1,500. Give me some resistance. 1,000. 25?
Yeah.
All right. 25. And how many? How many? 500. Thank you. All right. So now we have 500. We have very disparate numbers, right? So now we're going to hit clear again twice. Okay. Now we're going to just put in 1,500. I'll wait. Now hit X to the -1. Now hit plus. Now put in 1,000. X to the -1 plus 25. X to the -1 plus 500. X to the -1 is equal to, and that'll give us the reciprocal of all these resistances put together. So we just take X to the -1, enter, and we find that our total resistance is 22.9 ohms. Why is that lower than the lowest resistance? It's lower than the total resistance is always lower than your smallest resistance. One of your pure functional magic checks with parallel circuits is if you get a total resistance is higher than any one of the single resistances, you've made an error. Stop and go back. Okay, so that's your PFM check. All right, one more. You know what? We'll run over our time limit if we go one more. So we're going to stop.